Lesson 42 will be our first exposure to the different conic sections, and we will learn to use the equations for all four types of them. We'll talk about what the four types are, but we'll only learn the equations for circles today and how that works. Second topic will be exponential functions that have constants in the exponent, along with the variable that makes it an exponential function. So first, the definitions with some pictures for you. It's not necessary to get all of the words down on all of this, but conic sections are what you get when you take a double cone, which really means one of them turns like this and one of them tip to tip, so on top of each other like this. And if you take like a flat giant blade and slice through, depending on which way you go, you get different shapes. If you go straight across so that your giant blade is perpendicular to the axis that goes from the tip of the cylinder down through the middle, if you cut straight across, you get a shape that has a circle for its outline. And that's the one we'll talk about today. If you tilt it just a little bit so that it only goes through one of the two parts of the cone, you get a shape that is an ellipse, where this circle is kind of squished. The other two are parabolas and hyperbolas that look similar. If it is a parabola, it is tilted in such a way that it only goes through one of the cones. So this one went through the bottom part, but would be tilted enough that it would just always stay outside of the top. And in that case, you've got a parabola. If it's a little closer to vertical, when you slice it, it will go through both sections of the cone. This is just one of them. But you get this part down here, and you've got a matching part up here. So you get the hyperbola that has the two halves on it, with a space in between them. And here's another picture of the different ways that it cuts through to get the circle and the ellipse, the parabola, or the hyperbolas. So, for a circle, that's what we're going to talk about today. And you guys know, because you've used at some point a compass where you've got the little pointer and you have the pencil in it, and you put the pointer on the paper and it stays put, that's the center of the circle, and you spin the compass around so that you draw the circle. You're drawing things that are always this space, however far apart the pencil and the point are, and that's your radius. So you've drawn the points that are that constant distance away from the center. That's our locus definition for a circle. So if I want to write that down, if my center is HK, I'm saying that my radius is that constant distance. Oh, my distance formula, I'm going to take x minus h and square that, and y minus k and square that. That's my distance from the center HK to all of those xy's that I'm drawing. So then if I square both sides, I have what we call the standard form for the equation of a circle. And that is just when we then square both sides. We also talk about the general form of any conic section, and that's when we start off with x squared if there is one, y squared if there is one, x and y multiplied together if there is one of those terms, then just the plain x's, then the plain y's, then the constant, and it equals 0. And we'll do an example in a few minutes where we do both of those kinds of equations. So let's try this out with an example. We want the equation of this circle both standard and general here. And so first, I don't have to, but I could just draw it to make sure I know what I'm doing here. So I've got that center at negative 2, 8. If you are drawing a circle, you plot that point, because usually you're given the center, and then we go 5, 1, 2, 3, 4, 5, and do a dot. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In those 4 directions, and then we do the best we can to draw a circle that goes through those 4 points. If you have one that is going off your grid, because your grid doesn't have the numbers on it, change the scale. But you have to do some labeling to show what your scale is, but change it the same way both directions. Otherwise, it is not going to look like a circle at all. That makes what each left be 2 or whatever you need to make it fit in there so you can actually graph it. All right, so we start off with, there's our formula that we know we need to use. So we are going to plug in the center. So we are going to plug in for the standard form, x minus the negative 2 and square that, and y minus the 8 and square that, and then write down that that is either 5 squared or 25. And that is your standard form. And you can do the 5 squared or the 25 or both on that. But for standard form, you leave it with the parentheses so that it shows you just looking at it what the center has to be, that it's the opposite of the 2 things in the parentheses. Then to get general form, we simply FOIL things out and combine terms and get it in the order that you wrote down. So we have x squared plus 4x plus 4 plus y squared minus 16y plus 64 equals 25. Check my work, make sure I didn't mess up any plus or minus signs or multiply them. Jenna?
So wait, on that blue one, do you write both 5 squared or 25? Or you can just do
one or the other or both. I'm not going to be picky on that.
Okay.
The point is you can look at it and tell what the center and what the radius is. All right, so now that we have this one written out, general form had to start with the x squared and then the y squared, so we put those side by side. We don't have a term that has x times y, so that was a 0xy, so we skipped that. Then we needed just the plain x. The only one I have is the plus 4x, and just the plain y was the minus 16y. And then we need to put all of the constants together, and I had 68, and then I need to subtract the 25 from that, so that is going to give me a positive 43 equals 0. And that is my general form, and that is all that you have to do on circular forms. Questions? That part's pretty easy. Yes, Chloe?
So, would you have to box the...
Yes. Because this one asks for both, so we would have to have both of those in there as our answers. Anything else? All right, getting ready for the other topic. Remembering our translations is going to help us when we have constants in our exponential functions, in the exponents in those. So remember that if we translate right, that is when we subtracted something inside. You should already have all of this in your notes. If we want to translate left, we add inside. The left and right are kind of the opposite of what we're doing. Right is minus and left is plus. But if we're going up and down, then it's just tacked on at the very end on the outside, adding and subtracting. If we want to reflect across the x-axis, we make the f of x negative. And if we want to reflect across the y-axis, we simply make the x negative. Remembering these will help us with what we are going to do next. So the kinds of things we are doing with constants and exponents are things that look like this. I want to get at, y equals something to something that I know how to graph, but then there's one of these translations going on with it, so I can just shift left, right, or up or down on these. So what I am going to do with this is first, I want to get an exponent that starts with x, not with a minus, not with a 2, because if I can get the exponent to be x plus 2, I shift to the left 2. If I can get it to be x minus 3, I shift to the right 3. So, first thing I'm going to do, since I have a minus in front of the x, is I am going to factor a minus sign out of that. So y is 2 to the minus 1 times x plus 2. Would you agree with me that that exponent is the same as what I had? If I distribute the 1, I get and change the order, I get the same thing that I started with. So still the same problem. Then we know that if we had something to one exponent and then to another exponent, we would multiply those exponents. So those brackets that I just put in don't change anything at all about that problem. However, they let me remember, what is 2 to the minus 1? It is a half. So this is y equals a half to the x plus 2. That means just in the inside part where I've got the x, I have an x plus 2. That means that I am shifting y equals a half to the x to the left 2. The x plus 2 means I go to the left. Am I able to graph a half to the x? So I'm going to do dots just for the lattice points. Y equals a half to the x would have gone through 0, 1. Is it going to be increasing or decreasing? It's going to be decreasing. It's going to be an exponential decay. I would have had negative 1, 2, negative 2, 4, negative 3, 8, and negative 4, 16 would have been off my graph. Now I need to take each of those and shift them to the left 2 to get what I am really graphing. So this one is going to go to the left 2. This one is going to go to the left 2. This one and this one. One thing I didn't put up there, my original one had this as an asymptote, right? That asymptote is going to slide to the left 2. Does it look any different? It just slides on itself, so I still have the x-axis for my asymptote. So I fill in my real graph, and it is going to look like this. I can label my lattice points just by figuring out where I landed. I am at negative 2, 1. I am at negative 3, 2. I am at negative 4, 4. And I am at negative 5, 8. If I wanted my new y-intercept, I could say 0, a half to the 0 plus 2, I'd have a half squared. So my new y-intercept would be 0, a fourth. And so we try to come up with the coordinates for the lattice points and usually also for the y-intercept. Questions with that and what we're doing? Okay, let's do a couple more of these with a couple different variations. This one is similar. Y equals a third to the minus x plus 1. We want to figure out how to make it start with plus 1x, because we know how to graph fractions or integers to the x. So first thing we're going to do is we are going to factor out that negative 1. So we have f of x is a third to the negative 1 times x minus 1. Put just the minus 1 with the 1/3, and we have 3, and we have 3 to the x minus 1. Which way does that shift? Everybody point. If I take my x and it's now an x minus 1, which way does that shift things? Left, right, up, or down? So everybody's pointing good, shifting to the right. So this means we take 3 to the x, and we shift it to the right 1. So we're going to do what we did before. We're going to do dots for 3 to the x, 0, 1, 1, 3, 2, 9. We are going to shift each of those to the right 1. We had an asymptote on the x-axis. If we slide that to the right 1, does it look any different? So we still have the horizontal axis as our asymptote. So our real graph will look something like this. We can label those points just by thinking about where we landed on the lattice points. 1, 1, 2, 3, and 3, 9. We can get our intercept by plugging in 0, and we have a third to the first. So 0, 1/3 is our intercept. That is really not that hard. Last one, still similar, but one slight little difference. I want my exponent to start with x. So what do I need to factor out of it? I need to factor out a 2, which on this one makes it real easy. I basically am just putting the 2 with the base of 2. So this is really just g of x is 4 to the x. I don't need a shift on that. I know how to graph that. That goes through 0, 1, goes through 1, 4, and 2, 16, so off the grid before I get there. Nothing changed with an asymptote or a shift, and it just looks like that, and I had these points 1, 4, and 0, 1 on them. So, thumbs up, thumbs down, things from today making sense? Then the rest of our time will be work time.